Hello everyone, today we will start a new topic, matrices. So why we read matrices? Matrices is a powerful tool in mathematics and it is necessary in different fields such as physics, economics, geology, sociology and many more fields. So we will start matrices by giving some examples. Suppose Suresh has 10 books. We express this information in matrix form. This is an example of matrix. Let us take another example. Suppose Suresh has 10 books and 5 pens. We express this information in matrix form. This is also an example of matrix. Let us come to another example. Suppose Suresh has 10 books and 5 pens. Ram has 15 books and 9 pens. Geeta has 7 books and 3 pens. Now we will express this information in matrix form. 10, 5, 15, 9, 7, 3. These lines for books. This is for pens. This information for Suresh. This is for Ram and this is for Geeta. Now we will express this matrix in another form. Suresh, Ram, Geeta. Books, pens. Suresh has 10 books, 5 pens. Ram has 15 books, 9 pens. Geeta has 7 books, 3 pens. So these two matrices are different formats. So these are the rows. These lines are rows. And these lines are columns. Okay. So in first matrix there are 3 rows and 2 columns. In second matrix there are 2 rows and 3 columns. So we denote this row 1, row 2, row 3 and column 1, column 2. Here this is row 1, row 2, column 1, column 2 and column 3. Next come to another example. There are 4 unit tests in 3 different subjects, 3 topics. unit tests, test number 1, test number 2, test number 3, test number 4, and subjects mathematics, physics, chemistry. In test 1, mathematics 72, physics 68, chemistry 79. Mathematics 85, this is 75, 82. In unit test 3, 87, 78, 86. This is 94, 85, 92. So we express this information in matrix form. So how can we represent this? 72, 68, 79, 85, 75, 82, 87, 78, 86, 94, 85, 92. In this way we get this matrix. So there are how many rows and how many columns? 1 row, 2 rows, 3 rows, 4 rows, and column 1, column 2, column 3. So number of rows are 4 and number of columns here 3. So this is a 4 by 3 matrix and it is called order of that particular matrix. So what is the definition of matrix and order of matrix? So from this example, so we conclude that a matrix is an ordered rectangular array of numbers or functions. Okay, so this is a rectangular array and this is called a matrix, and these elements are called numbers or functions. These are the numbers here. So numbers or functions are called elements or entries of the particular matrix. Okay, got it? Now come to the point, order of matrix. So order of a matrix. Matrix have m rows and n columns. It's called a matrix of order m by n. So there are 4 rows and 3 columns. So it is called 4 by 3 matrix. So we denote the matrix A, and this is the form of a general matrix. This is the elements of the matrix is A, I, J, and its order is m by n. Here 1 less than equal to I less than equal to n, and 1 less than equal to j less than equal to n, and I and j are all natural numbers. Okay. So see this particular example. This is a 4 by 3 matrix. How many numbers? How many numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 elements. So got it? So in m by n matrix there are mn number of elements. So in 2 by 3 matrix there are 6 number of elements. Okay, and when we take 4 by 2 matrix we get 8 elements. If we take 5 by 2 matrix we get 10 elements. So these are the product value. 10 is the product value of 5 and 2. M and n has product value m by n. So we get that point. Okay. So we can number of element in m by n matrix is mn. Okay. We have books, and first example 1. Example 1 question is, consider the following information regarding the number of men and women workers. Men and women workers in the factories 1, 2 and 3. So the values are main workers, these are the values of factor 1, 2 and 3. Women workers, these are the values of factor 1, 2, 3. Represent the above information in the form of 3 by 2 matrix. Okay, we find example 1. Find a 3 by 2 matrix following this information. And what does the entry in the third row and second column represent? Okay, so we'll start 3 by 2 matrix. So 3 by 2 matrix, number of rows 3, number of columns 2. So there are 3 rows and 2 columns. 3 rows, so 30, 25, 25, 31, 27, 26. So row 1, row 2, row 3. This is column 1, column 2. So there are 3 rows and 2 columns. So this is a 3 by 2 matrix. Okay. Next, what does the entry in the third row and second column represent? So third row, second column represent, the value is 26. So third row, second column is 26. So now come to the element, general form of the element. So A is the matrix name and the element form is Aij. So the general form of this particular matrix is A11, A12 up to A1J and up to A1N, A21, A22, A2J up to A2N, AI1, AI2, AIJ, AIN, AM1, AM2, AM3, MJ, MN. This is the general form of the elements of the particular matrix Aij, where this is a M by N matrix, this is also M by N matrix. So we get, this is the element of first row, first column, this is the element of first row, second column, and all the elements like that. Let us come to next example, example 2. If a matrix has 8 elements, so come to the example number 2, there are 8 number of elements. What are the possible orders it can have? So we discussed previous examples. So there are 8 elements, that means there are mn number of elements. So mn number of elements from which matrix? M by N matrix. So first we have to find out the order pairs, possible order pairs whose product is 8. That means 8, the possible order pairs are whose product is 8. 8 into 1, 1 into 8, 2 into 4, 4 into 2. Okay, so we got 4 order pairs whose product value is 8. Okay, so the possible orders it can have. So matrix has possible orders, that means 8 by 1 matrix, 1 by 8 matrix, 2 by 4 matrix, and 4 by 2 matrix. So there are 4 possible ways. Next come to example 3. Construct a 3 by 2 matrix whose elements are given by example 3, whose elements are given by Aij is equal to 1 by 2 into modulus of I minus 3j. Okay, so we construct a 3 by 2 matrix. So general form of 3 by 2 matrix is A is the matrix name, and 3 by 2 means there are 3 rows and 2 columns. So A11, A12, 2 columns. Okay, A21, A22, A31, A32. So we find out this matrix by using this formula Aij equal to half into modulus of I minus 3j. Got it? Okay. So first find out this matrix. First find out A11. A11 is equal to half, value of I is equal to 1 minus 3 into j. This is 1. So that is equal to 1 minus 3, that is minus 2. Modulus of minus 2 is 2. Half into 2 is equal to 1. Next A12. Okay, half 1, I value 1, 3 into 2, that is equal to 1 minus 6 is equal to minus 5. Modulus of minus 5 is 5. So this is 5 by 2. Next A21, that is equal to half into 2 minus 3 into 1, that is equal to 2 minus 3 is equal to minus 1. So minus 1, modulus of minus 1 is 1. So that is 1 by 2. A22, that is equal to half into modulus of 2 minus 3 into 2. So 2 minus 6 is equal to minus 4. Modulus of minus 4 is 4. 4 by 2 is equal to 2. Next A31, that is equal to half into 3 minus 3 into 1, that is equal to 0. A32, that is equal to half into modulus of 3 minus 3 into 2, that is equal to 3 minus 6 is minus 3. Minus 3 the modulus 3, so 3 by 2. So we get all the values of matrix A and put these values and get the matrix. So A is equal to A11, that is 1. A12 is 5 by 2. A21 half. A22 2. A31 is 0. A32 is equal to 3 by 2. So we get our required matrix. Okay, so now we start types of matrices. So first of all we read column matrix. Okay, so what is a column matrix? A matrix is said to be a column matrix if it has only one column. In general form, A is the matrix name and the elements are in Aij form. So A equal to Aij of order m by 1 is a column matrix of order m by 1. For example, 1, 2, 4, minus 3. This is a column matrix. The order of this matrix is number of rows here 4 and column 1. So order of this matrix is 4 by 1 and it is also called column matrix. So next we'll read row matrix. Okay, what is a row matrix? A matrix is said to be a row matrix if it has only one row. Okay, so in general form, B is the matrix name. B is equal to Bij of order 1 by n is a row matrix. So it has order 1 by n. So for example, 1, 5, minus 6, 3. So here number of rows is 1 and number of columns are 4. So this order of this matrix is 1 by 4. Okay. So next we will start square matrix. So what is a square matrix? A matrix in which the number of rows are equal to number of columns. Number of rows are equal to number of columns. So it is said to be a square matrix. In general form, A is equal to Aij of order m by n is a square matrix of order m, or it is said to be order n also, because m equal to n. Okay. So for example, 1, 2, 3, 4, minus 1, 5, 0, 6, 9. This is a matrix. Number of rows here 3, number of columns is 3. So this is a 3 by 3 matrix, and it is also order 3 matrix. Okay. So the point to be noted, if A equal to Aij is a square matrix of order n, then the elements or the entries A11, A22 up to ANN are called diagonal of the matrix. So this is important. So here the diagonal elements are 1, minus 1, 9. In general matrix of order n, we can write A11, A12, A13, up to A1n, A21, A22, A23, A2n. This is order n. So AN1, AN2, AN3 up to ANN. So this is order n, and it is a square matrix, and A11, A22 up to ANN are called the diagonal elements. Okay. Now we'll start diagonal matrix. So a square matrix B is equal to Bij of order m, said to be diagonal matrix if all its non-diagonal elements are 0. That is, matrix Bij of order m is said to be a diagonal matrix if Bij equal to 0 when I not equal to j. For example, 1, 0, 0, 0, 2, 0, 0, 0, minus 1. This is a square matrix and order 3, because number of rows are equal to number of columns. So this is a 3 by 3 matrix of order 3 matrix, and the diagonal elements are 1, 2, minus 1, and other elements are called non-diagonal elements. Here the non-diagonal elements are 0. So it is called diagonal matrix. Now we will start scalar matrix. Okay. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Okay. So it is also called a diagonal matrix and all the diagonal elements are equal. That is any constant. We can choose any constant 1, 2, 3, C, K, etc. So in general form, B equal to Bij of order n is said to be scalar matrix if Bij equal to 0 when I not equal to j and Bij equal to k when I equal to j. So all non-diagonal elements are 0 and diagonal elements are k. So for example, so this is a scalar matrix of order 2. This is a scalar matrix of order 3. Okay, so here the constants, all the diagonal elements are equal, that is -5. So it is called a scalar matrix. Okay, now we'll start identity matrix. So what is an identity matrix? A square matrix in which elements that in the diagonal are all 1 and rest are all 0. It is called identity matrix. So in general form, A equal to Aij of order n is an identity matrix if Aij equal to 1, if I equal to j, and Aij equal to 0 if I not equal to j. We can denote it by the identity matrix by In, or it is simply called I. So taking examples, 1 0 0 1. This is a identity matrix of order 2, and we can say this is I2 matrix. Okay, 1 0 0 0 1 0 1 0 0 0 1. This is identity matrix of order 3 and it is called I3. So got it? Next we will start zero matrix. What is a zero matrix? A matrix is said to be zero matrix or null matrix if all its elements are 0, and it is denoted by O. Okay, so for example, 0 0, all the elements of this matrix is 0, so this is a zero matrix. This is also an example of zero matrix. This is also called a zero matrix. Okay, so we'll discuss next part in next class. Thank you.